Are you interested in understanding how to do OSPF routing within CISCO Packet Tracer? Well, then this tutorial is for you. I'm going to be showing you how to build the network on screen, as well as how to set up OSPF routing between the three routers so that you can send pings between any of the PCs without any issues. So if you're interested in that, keep watching this video. I also have other videos on static routing, RIP routing, and I'll be having one coming soon on EIGRP routing. Alright, so I'm going to get started building our topology. So I'm going to come down to network devices, into routers, and I want to grab the PT empty. Now I want to grab 3 of these and place them out like so. And I want to place this middle one a bit lower because they're going to all connect within one another. Then I'm going to come to switches. I'm going to select the 2960 and I'm going to place 3 of those and I'm just going to align them up like so. And now I'm going to come to the, I just want to change that slightly, yep. Now I'm going to come to the end devices, end device and the PCs. So I want 6 PCs in total. I'm going to have 2 per switch. So I'm going to place these and just align them. Oops, I didn't mean to open that window. Like so. Alright, so now I've got my PCs. They're a little bit close to the switch, so I might just drag them all down slightly just so they are a little bit further to help with our viewing our connections. Alright, so now I need to draw in our connections, but first I need to set up our routers. So I'm going to open up the router. Now because I've selected to use the PT router empty, it means that I can configure it how I want. So what I need to do is I need to turn it off, and then I need 2 of these PT router NM1S. They add my serial port which I'll use to connect to the other routers. And then I need 1 PT router NM1 CFE, which adds a fast Ethernet that I can use to connect to my switch. Now you can use other configurations. This is just what I'll be using within this tutorial. So you turn it back on and then repeat the same process on the next one. So I'm going to turn it off. I'm going to grab the 1S, 1S, 1 CFE. And it's important to fill from the right to the left because that's how it's like set up in configuration. So you'll notice you got serial 001020 because it's filled right to left. Okay, and I'm going to do the final one, 2 serials and 1 CFE, and turn it back on. Alright, now I'm going to draw in my connections. So I'm going to connect each device up. So I'm connecting the fast Ethernet 0, and then I'm just going, because it's out of the screen, connected to O1 and O2. And I repeat again on the next switch, O1 and O2. And again on the third. And now I'm going to connect the switches to the routers. What I like to do is to select the very last switch port and then use that for connecting to the router. Because that way then if say I wanted to add another PC in later, I have FA03 free for that PC. So I'm going to do the same for the next one. And again for the final one. So now I have those. To connect the routers, I want to use the serial DTE. And I'm going to select 00200. Then I'm going to do 10. And what I want to do is I want to do 10 over here. So you got 10 and 10. And then here I'm going to do 10 to 00. So 00 to 00. 10 to 00 and 10 to 10. I realize because you can't fully see the connection names here, which is a bit annoying, but that's fine because we'll put in labels shortly. All right, so we've now got all of our fiber, like all our connections put in. I'm going to go through and I'm going to label what we're going to call like the IP addresses of all the devices. So I'm going to click this little note thing. And so this switch is going to fall under 1.1. This one will be 2.1. And this one will be 3.1. So then this PC will be 192.1.10. This one will be 192.168.1.11. This one, 192.12. 192.168.2.13. 192.168.2.14. And finally, 192.168.2.15. So now I'm just gonna move all of them to be like close enough to where they're meant to be, because it doesn't really like place in typically near where they are. And then we've just got to draw in right in our routers up here. So what we're going to have is over here, the first port will be 10.0.0.1, and then the other one will be 12.0.0.1. So the connection from this router 0 to router 1 will be 10, and from router 0 to router 2 will be 12. So then we'll have here would be 10.0.0.2, and then this side is going to be 11.0.0.1, because the connection from router 1 to router 2 will be our 11. So over here I'm going to do, we want 11.0.0.2 and 12.0.0.2. So that is all of the labeling of the connections that we're going to have. Now we need to actually go through and set that up. So I'm going to start by going through all of the PCs. So I'm going to open them up, I press desktop, IP configuration, and then I need to fill out its IP address, and also I need to fill out the default gateway. So I'm going to repeat this on the next one. 12. Then over here, this one will be the next. This will be 2.12. Did I do that one right? It's meant to be 11. 10, yeah. Okay, and the next one, this one is $2.13. And now over to PC4. This one is a 3.1, 14. And finally, PC5 is 15. So now all the PCs have got their IP addresses and their default gateways. So now the next step is to set up our routers. Alright, so now I'm going to configure the routers. I just went and added in a little thing into my little notes here that show what the actual serial ports are. Now, I think this would be a really beneficial thing for you to add in as well, just so that when you're connecting this all up, you're able to make sure that you are setting up the right ports. Because as you can see here, we can only see one of the ports. You have to drag around the routers to be able to see what port is correct. So just keep that in mind when you come to set up your network. It might be beneficial so that you can write these in, and that way when you're setting it up, you know, okay, this IP address goes to this port. So with that, let's start setting up these routers. Okay, so I need to set up a few things here. We need to set up our connection to the switch, and then our connection to the two other routers, and then our OSPF connection. So I'm going to come into the CLI mode here. I'm going to press return, and then I'm going to type enable. I'm going to do conf t. I'm going to set the host name to be R0. And now I'm going to set up for the switch. So my switches are always FA20 for all of my routers. So I'm going to type interface FA20, enter, IP address of 192.168.1.1. subnet mask of 255.255.255.0, enter. No shutdown, exit. So now I'm going to set up our connection to router 1, and router 1 lives on the 10 network. So I'm going to go to the SE00. So interface SE00, enter. IP address of 10.0.0.1, subnet mask of 255.0.0.0. I apologize for the fact that I say O and 0 interchangeably. Clock rate of 64,000. No shutdown. Exit. So now I'm going to configure our 12, which is 10. So interface SE10, enter. IP address of 12.0.0.1, subnet mask of 255.0.0.0, enter. Clock rate 64,000, enter. No shutdown, exit. So now I've configured our connection to the switch, our connection to router 1, and our connection to router 2. I now need to set up our OSPF routing. So here I need to go into this mode, so I type router OSPF 1. Now I need to set up our 3 networks, and you kind of do an interesting thing here. So basically you want to create a wildcard of a mask. So we actually have to do it a bit, it's a bit strange, but it works. So we need to do network. We're going to set up our first one, which is this switch. So network 192.168.1.0. And now we do the inverse of the subnet mask of the 10 and 12. So we do 0.0.0.255. And then I'm going to type area 0. Now I'm going to do it for the next one, which is 10. So network 10.0.0.0. And here the subnet mask will be the wildcard reversed of the 192 network. So I do 0.255.255.255. And again, I do area 0. And now because the final one's quite similar, it's just changing it to 12, I'm going to press the up arrow on my keyboard and then the left arrow to go across and change it to just be 12 here. And then I'm going to press enter. So now I've configured our OSPF routing for router 0. So I'm going to type exit, exit, write memory, exit. So router 0 is now configured. So we can see that we've got some green arrows here, so things are starting to work. So now I'm going to come to router 1, to CLI, press enter, and I'm going to configure up our first switch connection, which is to the 2.1. So I'm going to write enable conf t, host name is R1, interface FA20, IP address is 192.168.2.1, and subnet is 255.255.255.0. Enter. No shutdown. Exit. Okay, that did work. Okay, so now I'm going to configure our 10, which is connected to SE00. So I'm going to type interface SE00. IP address is 10.0.0.2. Subnet mask is 255.0.0.0. Enter. No shutdown. Exit. And now I'm going to configure our connection to router 2. So this is interface SE10. I'm going to give it the IP address 11.0.0.1. Subnet mask of 255.0.0.0. Enter. Clock rate of 64,000. No shutdown. Exit. And now again, I need to do the OSPF configuration. So here I'll write router OSPF 1. And I'm going to basically be doing the same process of the inverted subnet masks and that sort of thing, but here we'll give it 10 and 11 not 10 and 12, because that's its two connections. So we're going to do network 192.168.2.0, the inverted subnet mask of 0.0.0.255 with an area 0. And then I'm going to do network 10.0.0.0, inverted subnet mask of 0.255.255.255, area 0. And then I'm going to again press the up key, go across to the left, oops, okay, up key, across to the left, and change that to be 11. Press enter, and then I'm going to do exit, exit, write memory, exit. So now we have our router 0 connected, a router 1. Now we need to move over to our router 2. So I'm going to come into the CLI mode again. I'm going to press return. I'm going to type enable conf t hostname R2 interface FA20 IP address of 192.168.3.1 255.255.255.0, enter, no shutdown, exit. And now I'm going to configure our 11 one first, which is 00, so interface SE00, IP address of 11.0.0.2, subnet mask of 255.0.0.0, enter, no shutdown, exit. And now I'm going to configure our 12, which is 10, so interface SE10, and I'm going to do IP address 12.0.0.2, subnet mask of 255.0.0.0, enter, no shutdown, exit. And now I need to configure our OSPF again. So I'm going to do router OSPF 1, and I'm going to set up our subnet mask for the switch first. So network 192.168.3.0, inverted subnet mask of 0.0.0.255, area 0. Now I need to set up for the 11 and the 12. So network 11.0.0.0, inverted subnet mask of 0.255.255.255, and then area 0, enter. I'm going to do the up arrow, go across, and change that to be a 12, and press enter. So now I'm going to type exit, exit, write memory, exit. So we should now have our 3 routers set up and configured. So what we can actually do is we can go into any of these routers and press enter, and we can type show IP route, and it will actually show us all the information. So the 0 of the O ones here are our OSPF. And what we can actually do is we can filter by that. So we can do show IP route O, and it shows us just our OSPF configurations for our routers and setup. So if we want to go to 11, we go via 10 or via 12. Then if we want to go to 2, we go via 10. If we want to get to 3, we go via 12. So it's telling us like what the routes are that it's going to take. So now with that, we can test pinging and connectivity of the network. So we can start with PC0. I want to come to desktop, command prompt, and I'm going to try ping at PC4. So ping 192.168.2.14. Now the first one will fail, as if you've watched my other videos, the first one will fail because it is trying to do the whatchamacallit it, and I've just realized why it's failing. It will do the broadcast of ARP. This is actually 3. I have put a typo in there all along. Let me just double check that I set that up right. Yeah, 3. Okay, come back here again. There is no 214 in the network. So yeah, the first one will fail because it's sending out the ARP broadcast to understand how it gets across the network, and then the rest will be successful. So my apologies for having the note be incorrect, but it does actually work when I'm picking the correct device. So now I'm going to try PC3. Once again, the first one will fail, and then the rest will work correctly. Yep. So now what we can do is we can actually try going into simulation mode, because it should show us how OSPF works. So what I'm going to do is I'm going to try do a packet from 0 to 3. So it should come down through router 1 because that's our fastest method. I'm just going to speed it up because it is quite slow. We'll go all the way up. Okay, let's come down, and it's gone successfully back across. So it has worked. Now let's try going to PC5, and we're going to see what route it takes because it's got 2 options. Now you can see here we've got some ARP messages, so it's actually having difficulty communicating across. So this one is going to say it's failed. However, if you remember when I was showing you the ping, the first one fails. If we repeat this, it's going to work correctly because it now has that ARP information, as you can see. So if you do a network and then the very first time it fails, always do it again before you jump to something's wrong, because there's a chance that it actually does work. It just needed to understand the ARP table and the information to be able to get across the network. So there you have it. That's how you can build a network with multiple routers and use OSPF routing to communicate between the different routers. I hope this video helped. I also have one on a static routing, RIP routing, and I'm about to film one for EIGRP routing. So if you've got any suggestions or requests, leave them in the comments. But if not, I will see you in the next video. Bye!